shall send some videos of demonstration of live experiment, and during that experiment, required data are collected and it will be just supplied to you. So during the class hour, we'll discuss behind the background theory as well as procedures, precautions, etc., how the experiments are performed, what are the different important conclusions. So how you will just tabulate the results, observation, and from that how you will come to the conclusion, and what are the different graphs, etc., you have to provide in support of your conclusions. We'll discuss these issues. So before we just start today's experiment, I did not send any demo video, file for demonstration of experiments. Today, I hope during the class hour, I will just show the particular experiment demo in video. I'll share the screen with you. But in subsequent classes, I shall send the video beforehand. And you will just observe the video and then come to the class. During the class, we will discuss different issues. And if there is any question regarding the demonstration video, we'll just clarify. So first we just start with our attendance. Roll 59.
Yes, sir. Yes, sir. 59.
Okay. Roll 64. Roll 69.
Present, sir.
Okay. 73. 88.
Present, sir.
Okay. 94.
Present, sir.
98.
Present, sir.
Okay. 100.
Present, sir.
Okay. 102.
Present, sir.
Okay. 103.
Present, sir.
Okay. 104.
Present, sir.
Okay. 106.
Present, sir. Present, sir.
Okay. 112.
Present, sir.
Okay. This is Ritankar Das.
Present, sir.
Sir,
Okay.
73 present, sir. I just lost my internet connection for a while.
What is your roll number? 73.
73.
Sayok Barui.
Present, sir.
Okay. Jaydeep Bishwas. Shubhadeep Nashkar.
Present, sir. Present, sir.
So anyone will come? 2 students are absent today. Jaydeep Bishwas, Azhar Imam. Well,
Sir.
yes.
Sir, Azhar Imam has a medical condition. That's why he is admitted at a hospital right now.
ঠিক আছে, তা যদি যখন সম্ভব হবে ওকে একটা মেল করতে বলবে আমাকে যে এই ব্যাপারে।
ঠিক আছে স্যার।
অসুবিধা আছে। I have given your attendance, শুভদীপ। আর এটা সম্পর্কে সমস্ত ক্লাস রেকর্ডিং এটসেট্রা সমস্ত কিছুই তো পাঠিয়ে দেওয়া হবে তোমাদের। সুতরাং এই দিক থেকে কোনো অ্যাটলিস্ট অনলাইন ক্লাসে সেদিক থেকে কোনো অসুবিধা হওয়ার কথা না। So we'll go to our first experiment now. Let us take some time to set this experiment. So we'll study the first experiment, which has the title Determination of Mass Moment of Inertia and Radius of Gyration of a Flywheel. So first, what is a mass moment of inertia? It is some kind of resistance of an object against any attempt to change the state of its rotational motion. Resistance against any attempt to change the state of its rotational motion. Inertia or mass, usually the resistance against any attempt to change the state of translational motion. Its counterpart for rotational motion will be mass moment of inertia. You know this thing, and I hope in this semester and sometimes to some extent in the previous semester, in the course of engineering dynamics and in this semester advanced engineering mechanics, you will learn in details about mass moment of inertia. Now, what is the radius of gyration? Radius of gyration is the distance from the axis of rotation where the entire mass of a distributed object can be thought to be concentrated without changing any state of its rotational motion. Instead of the entire distribution of mass, we can concentrate all the mass at a point, and that point will be situated at a distance from the corresponding concerned axis of rotation, which the distance is equal to the radius of gyration. Mathematically, the expression of radius of gyration is square root of moment of inertia divided by total mass. So this moment of inertia terms, as you have learned, it is not as simple as it is defined in this manner. So for a three-dimensional rigid body, you will learn that, particularly in this semester advanced engineering mechanics, the moment of inertia is expressed by a matrix. In that matrix, 3x3 matrix, you have 3 diagonal terms and 6 off-diagonal terms. Now, this matrix will be symmetrics, and as a result, among the 6 off-diagonal terms, there will be 3 independent quantities. Now, there will be 3 diagonal quantities and 3 independent off-diagonal quantities. Each quantity is a scalar quantity representing some physical quantities, which is certain kind of resistance against certain rotational motion. Particularly, this diagonal term will define as moment of inertia. If you set 3 mutually perpendicular axes inside the object, fixed to the object, whose moment of inertia we are going to determine, then about each axis you will get one moment of inertia term, and that are expressed as the diagonal term of that matrix. And off-diagonal terms will give the product moment of inertia or product of inertia. The significance of product of inertia is that for a three-dimensional rotation, if you try to rotate the object about certain axis, sometimes due to the distribution of mass, the resistance is felt about another perpendicular axis. That resistance, what is the relation between the resistance, relation between the effort and acceleration between two different axes. Effort is applied along one axis, angular acceleration or the rate of change of rotational speed, rotational velocity is happening in another axis. So what is the relation between these two? That is dictated by that moment corresponding product of inertia. So we will not go into details because that is much more theoretical aspect is there, which you will study in your advanced engineering mechanics course in details, obviously. So for our case, we'll consider the moment of inertia term rather than product of inertia. Now, you also know in your theory course, advanced engineering mechanics, that if the three-dimensional object has an axis of symmetry, then product of inertia which involves that axis of symmetry, that is relating the torque about that axis with respect to the angular acceleration about another perpendicular axis. That is the product of inertia. That product of inertia will be zero associated with that axis. So we'll consider a flywheel. What is a flywheel? Flywheel is a energy storage device. It is a massive wheel. You can say this is a massive wheel. So if there is a power generating device or power consuming device, what is the example of power generating device? Like turbines, like IC engines, or power consuming device like pump or compressor, like that, which undergo rotational motion. Using this flywheel, we can store the kinetic energy from a power generating device conveniently. Now, these power generating devices are connected to certain load, which will run by that power generating device, by generator or by turbine or that IC engine. So the power cycle, in the power generation cycle, always the power output will not be equal. It is not a steady, at a steady rate, it will be generated. I hope you have learned about in thermodynamics. Thermodynamics courses, I think you have attended in your second year, first semester class. Is it? Or
First year, second semester.
First year, second semester.
Right. So in that class, did you learn about Otto cycle, diesel cycle, etc.? Did you learn this thing? Petrol cycle, thermodynamic cycle for petrol engine, thermodynamic cycle for diesel engine. You did not hear
No,
about
sir.
this. Okay. So I hope in that case, IC engine course, there is a course on IC engine. In that case, you will learn in details. The cycle means, a thermodynamic cycle means cyclic repetition of a set of thermodynamic processes. During these processes, at some stage, power is developed within the engine. At some other stage, power is consumed. But the net effect will be a net power generation from power delivering system. So if you do not know these things, so I will not go into details, but you must see that for a four-stroke engine, you know that most of the heavy vehicles are of four-stroke engine and some two-wheelers are of two-stroke engine. Four-stroke engine means one thermodynamic cycle will complete in two complete revolution of engine crankshaft. Two complete revolution of engine crankshaft will comprise four complete linear motion or stroke of piston. One stroke for top to bottom, another stroke to bottom to top. Completes in one crank revolution. Then another stroke of top to bottom and another stroke of bottom to top completes in next revolution. This comprises 4 stroke, and in 4 stroke diesel engine or petrol engine, this 4 stroke corresponds to 4 thermodynamics processes. These processes are called compression, ignition, power, exhaust, intake. Intake, compression, power, exhaust, or exhaust, intake, power, exhaust, intake,
Compression power.
compression, power. Exhaust, intake, compression, power. One after one, it is repeated. So this is called a 4-stroke engine processes. Now, during this process, in power stroke, a very high amount of power is delivered by the engine. But during compression stroke, you have to compress the gas inside the engine. That is why you have to do the work from outside. So this is a power consuming section. Net effect in entire 4-stroke cycle, that total power delivery will be very high. But at every instant of time, power delivery is not smooth. So sometimes engine will need power, obviously maybe comparatively less amount of power. Sometimes engine will deliver power. Now when engine will deliver power, then that power, in that phase of cycle, the total power, total energy released may be excess compared to compared to the total energy required at that stage for the load to which is connected to the engine. Load can be run with a less amount of energy than that energy released in that stage, say in power stage. So what we will do with the excess of energy? So if you attach a flywheel with the crankshaft, then with the excess of energy, crankshaft will accelerate to a very high speed. And during the acceleration procedure, within the flywheel, kinetic energy is getting stored. Now come to the compression stroke. Just before the power stroke, there is a compression stroke. So after the power stroke, you will move through 3 stages. Then you will come to the compression stage. In the compression stage, the engine needs external energy, external work done to work with. So that energy or that work done will compress or will move the piston against the gas pressure inside. So that gas will be compressed to an appropriate thermodynamic state to deliver power. During the compression stage, certain power is needed. That power will be delivered from the kinetic energy stored in the flywheel. In that state, flywheel will be decelerating and supplying power to the engine piston. So that is the role of flywheel usually. I have given an example of a flywheel which is attached to an IC engine. Similarly, during operation of a turbine generator system, this load fluctuation will happen frequently. When load fluctuation happen, obviously demand of load will increase or decrease. In that case, you have to supply the power. When you supply the power, you have to decelerate the flywheel, which will store the energy. And when you will store the power, then you will accelerate the flywheel in order to the fact that flywheel will gain kinetic energy. This operation will do continuously. Now, details about this flywheel energy exchange you will learn in your 3rd year course of dynamics of machine. But before that, we'll introduce the term flywheel and its role. Is there any question on the role of flywheel?
স্যার
Yes.
স্যার মানে বুঝতে তো পারলাম, বাট ব্যাপারটাকে ভিজুয়ালাইজ করতে পারলে বেশি বেটার হতো।
আমি ফ্লাইহুইলের এটা দেখাবো, এক্সপেরিমেন্টটা দেখাবো। ফ্লাইহুইল ইজ নাথিং বাট হুইল। এক্সপেরিমেন্টটা দেখানোর সময় দেখবে একটা স্টেজে ফ্লাইহুইলটা এক্সেলারেট করছে আর একটা স্টেজে ডিসেলারেট করছে।
আচ্ছা ঠিক আছে স্যার।
একটা স্টেজে অ্যাক্সিলারেট করছে আর একটা স্টেজে ডিসিলারেট করছে। যখন অ্যাক্সিলারেট করছে ও কাইনেটিক এনার্জি গেইন করছে। Obviously mathematically you understand either gaining kinetic energy or increasing velocity or acceleration, they are similar phenomena, different expression of similar phenomena. In another stage flywheel will decelerate.
স্যার বলছি যে একটা স্টিম লোকোমোটিভে তার মানে আমাদের চাকাটাই ফ্লাইহুইল?
না, ওখানে চাকা ছাড়াও
ওটার সাথেই তো কানেক্টেড
actually
আছে।
there will be a flywheel. There will be a flywheel attached to the engine. Engine will deliver power to certain rotational actually what you observe in a steam locomotive is the actual engine is a slider crank mechanism.
হ্যাঁ
Do you know about slider crank mechanism?
হ্যাঁ
Then crank is a rotational element and slider is a reciprocating element, and crank is attached to a crankshaft, and on the crankshaft at certain end one flywheel must be attached. You will represent this slider crank mechanism with a line diagram. There is a line to represent the crank which will rotate in a circle. There is a line to represent the connecting rod, and there is a block to represent the slider which is attached to the piston. The slider will undergo reciprocating motion, crank will undergo rotational motion, and crank is hinged at a point. That hinge point signifies the position of the axis of the crankshaft. Crank is a projected part from the crankshaft. That crankshaft will carry at other end a wheel. That wheel will rotate about the same axis. It is rigidly mounted on the crankshaft. When crank rotates, wheel rotates. At a certain stage, crankshaft accelerates, certain stage, crankshaft decelerates. As a result, wheel will accelerate, wheel will decelerate. This is the simple phenomena of flywheel. It can be discussed in details in your dynamics of machine course in third year. Here we'll just see what is the moment of inertia, how a flywheel moment of inertia will be determined experimentally. So in this case, for the case of energy storing in the flywheel, the moment of inertia of the flywheel about the axis of rotation is very much important. So that moment of inertia and associated radius of gyration will determine. So this is the actually observation chart. This chart I will provide you to complete the report. So this is a schematic arrangement of a flywheel. A flywheel is mounted on a shaft, circular shaft, which is mounted on a set of bearings, two bearings at two ends. So how we will determine the moment of inertia of the flywheel? Actually, with the shaft of the flywheel, we have attached a rope. One end of the rope is tightly attached with the shaft. Other end of the rope is free and a falling mass will be attached with it. Now, from a certain measured height, this mass will be released from rest. As this mass will release, this rope will be unwound from the shaft surface. As a result, it will apply a tension tangentially to the shaft surface, which will give certain torque about the axis of rotation of the shaft. Till this mass is falling with acceleration, this torque will be positive and it will accelerate the flywheel. It will create an angular acceleration in the flywheel. Now, when the mass will strike the ground, at that moment, tension in the rope will become zero. Rope will become slack. As a result, that tangential force which will provide the torque will be absent. At that time, flywheel will decelerate. So there must be certain counteracting moment which will decelerate the flywheel. That counteracting moment will come from the frictional resistance in the bearings. This is one view of the flywheel assembly. This is the side view. This is the shaft, position of the flywheel shaft around which we have attached the rope. And at the end of the free end of the rope, we have attached this mass. So from the bearing, certain frictional moment will be applied. This frictional moment will act throughout the angular motion of the flywheel, and it will act against the angular motion. On the other hand, in the first stage, when this block will fall in downward direction under the action of gravity, additional moment will be acting due to the tangentially acting tension in the rope. So if you draw the free body diagram, it will be looking like this. So this is the free body diagram, flywheel and the shaft. This Ry and Rx, these two forces are two radial forces, component of reaction provided by the bearing on the shaft. So one vertical resistance and in this bearing, another vertical resistance, vertical support reaction in this through this bearing, another vertical support reaction through this bearing. When you sum them up, it will give Ry. Similarly, one horizontal reaction in this bearing and another horizontal reaction in this bearing will give you Rx. Ideally, they are acting through the center of the flywheel or center of the flywheel shaft. So they will provide no moment about the axis of rotation. Now this force P is due to the tension in the rope during the stage of falling of this mass. And this is the frictional torque, which is provided by the bearing friction. And during the course, this frictional torque will remain constant. It will act in the direction opposite to the flywheel rotation and try to resist the flywheel motion. So when there will be no tension P in the rope, only frictional torque will act and it will try to decelerate the flywheel. Now frictional resistance will assume it will remain constant, a constant quantity. It is not dependent on flywheel velocity, not dependent on flywheel rotational angle, not dependent on flywheel acceleration, neither is dependent on time. It will be constant. Now from this free body diagram, this is the free body diagram of the falling object. It is acted on by two forces. One is the tension in the rope upward, that is opposite to the tension here. Another is the self-weight mg. Obviously, the self-weight of the flywheel will also act. I did not mention here, but it will pass through the axis of rotation of flywheel. That is why it is also not creating any moment about that axis. Now, from the free body diagram of the flywheel, this is the free body diagram of the flywheel. You will observe that if you take the moment about the axis of rotation of the flywheel, that moment will be total moment of the external forces will be R0 cross P. R0 is the radius of the flywheel shaft minus M friction. This is equal to I, which is the moment of inertia of the flywheel about its axis of rotation, times alpha 0. Alpha 0 is the angular acceleration during accelerating stage of this flywheel. During this period, if you observe the free body diagram of this falling object, you apply the Newton's law, it will be mg minus p is the total external force acting on the object. It will be equal to mass times downward acceleration of the object. So downward acceleration will be dictated by not only mg, but also this tension P. So after the body hit the ground, the body will come down this height h and it will hit the ground. After the body hit the ground, p will become 0. And from the equation, this equation will change. In that case, we'll write minus I alpha 1 equal to minus m friction. M fric means frictional torque. It will be acting in the opposite direction of flywheel rotation, and it will remain constant till the flywheel rotate. And minus alpha 1 is the angular deceleration during this stage. The previous stage, the angular acceleration is alpha 0. Here, angular deceleration alpha 1. Since it is deceleration, we are writing here minus alpha 1. So from these two equations, we'll find that I into alpha 0 plus alpha 1 equal to R0 into P, R0 cross P. Since this m fric or frictional torque is constant, you just change the sign in this equation and add this equation with this equation. Frictional torque will be cancelled, or use other word, you will just substitute the frictional torque in this equation. And also from this equation, you can substitute the expression of P. So from these equations, you will find that I will be equal to m r0 g minus a. A is the acceleration of the falling object, divided by alpha 0 plus alpha 1. So one working formula for determining the flywheel moment of inertia has been obtained. But here you have to know alpha 0, alpha 1 and a. G is acceleration due to gravity, you know. R0 is measured quantity, it is provided. M is the mass of the falling object, which is also given.
Sir,
So, yes.
স্যার বলছি যে আদার মানে ওই দড়ির আদার মানে ওই প্রান্তটা তো আমার ফ্লাইহুইলের অ্যাক্সিসের সাথে কানেক্টেড ছিল, তো যখন
ফ্লাইহুইল
মানে
অ্যাক্সিসের সাথে না, ফ্লাইহুইলের সারফেসের সাথে, ফ্লাইহুইলের উপর যে শ্যাফটটা আছে, শ্যাফটের সাথে বাঁধা ছিল।
হ্যাঁ মানে এবার ওটা তো
ডেমনস্ট্রেশনে দেখানো হবে ওই প্রান্তটা বাঁধা ছিল, কিন্তু যখন তোমার কোশ্চেন হচ্ছে যখন মাসটা পড়ে গেল তখন কি হচ্ছে, তাই তো?
না, আমার কোশ্চেন হচ্ছে মাসটা পড়ে যাওয়ার পরে ওই মোমেন্টে তো টেনশনটা জিরো হচ্ছে, কিন্তু তারপরে তো ওটা ফ্লাইহুইলটা যখন ঘুরছে তখন তোমার তুলে নি,
রোপটা তো স্ল্যাক হয়ে যাচ্ছে, রোপটা তো গুটিয়ে আসছে, মাসের উপর গুটিয়ে পড়ে যাচ্ছে। একটা টাইম ওই যে জায়গাটা বাঁধা ছিল ওটা খুলে যাবে।
আচ্ছা মানে রোপটা অনেকটা বড়, অনেকটা পাকানো আছে আর কি।
হ্যাঁ, পাকানো আছে,
রোপটা খালি খুলতেই থাকছে খুলতেই থাকছে। আচ্ছা আচ্ছা, বুঝতে পেরেছি।
তার মানে আমাকে we have to determine now alpha 0 angular acceleration of flywheel, alpha 1 angular deceleration of the flywheel in the second stage, and a the acceleration of the falling object. So for this we'll take this working formula, kinematic relationship. The falling object is released from rest from a height, known height h, and we'll measure the time taken by the falling object to fall from that height to the ground. That time is t1. That time is t1. So from kinematic relationship, we can write h equal to half a t1 square. It is starting from rest. So from this, we can get the expression of the acceleration of the falling object. Okay. Now, the acceleration of the falling object from this expression, so we can find the velocity of the falling object just before it touches the ground. That velocity is v equal to at1. at1. Now at that instant of time, the same velocity will be considered at the end of the rope, which is attached to the flywheel shaft. The rope is taut. Each point on the rope will undergo same velocity. So the point other end of the rope, which is attached to the shaft, that end also undergoes the same velocity at that final instant. at t equal to t1. So surface speed at that point of the flywheel shaft, at t equal to t1 will be equal to v. So
Sir,
yes,
sir, এটা আরেকবার বলবেন।
so this v is the speed of the falling object just before it touches the ground. The falling object is connected with the rope and rope is taut, and it is also tightly wound around the flywheel shaft. The end of the rope which is attached to the flywheel shaft, at that instant it will have the same speed v at t equal to t1. So this rope is in turn rotating the flywheel shaft. So flywheel shaft has the same tangential velocity component at that instant of time, that is equal to v. If flywheel shaft has the radius r0, then the angular velocity of the flywheel omega 0 can be expressed in this manner: omega 0 into r0 equal to this v. Is it okay?
Yes, sir.
So we found omega 0, that is the angular velocity of the flywheel, which we denote as the maximum angular velocity. Why? This is the end of the accelerating stage. After this stage, the falling object will strike the ground and rope will be slack. So this is the maximum angular velocity of the flywheel. So this angular velocity has been achieved from a value of 0 through a period of time. Similarly, it is through a period of time through an angular acceleration alpha 0. So alpha 0 is nothing but tangential acceleration of that point on the surface of the shaft divided by r0. This is the last expression. As omega 0 equal to v by r0, alpha 0 equal to a by r0. So alpha 0 is known. So what is the angular deceleration? Alpha 1, that we have to know. We have known a, acceleration of the falling object. We have known alpha 0, angular acceleration of the flywheel during the first stage of motion. Now we have to know the alpha 1, angular deceleration of the flywheel during the second stage of motion. Now with alpha 1 deceleration, the flywheel will slow down. Its angular velocity omega 0 will gradually decrease to a value equal to 0. Now, after starting this experiment, after starting to count the time, say T2 is the time elapsed, total time elapsed when the flywheel come to rest again, completing two stages, one accelerating stage, another decelerating stage. So we can say during the interval of time T2 minus T1, flywheel will decelerate. During T1, flywheel will accelerate. During T2 minus T1, flywheel will decelerate. If angular deceleration is alpha 1, then during this interval of time T2 minus T1, flywheel velocity will reduce at a rate alpha 1 from omega 0 to a value equal to 0. Then from kinematic quantity, we can write omega 0 equal to alpha 1 into T2 minus T1. Or we can write 0 minus omega 0 equal to minus alpha 1 into T2 minus T1. 0 minus omega 0 means the final speed at this stage. Omega 0 is the initial speed at this stage. Alpha 1 is the angular deceleration. T2 minus T1 is the time interval. So from this expression, we can find what is alpha 1. Actually, during the experiment, we'll measure this h, we'll measure this time interval t1. Yes.
স্যার মানে আমরা টাইমের ফর্মে কেন করতে মানে চাইছি, মানে যদি এটা তো নর্মালি এনার্জি কনজারভেশন থেকেই হয়ে যাবে।
এটা তো থিওরিটিক্যালি তুমি এরিয়া মানে এনার্জি কনজারভেশনটা তুমি কি করে মাপবে, এনার্জিটা কি দিয়ে মাপবে? এক্সপেরিমেন্টের সময় তুমি মাপতে পারো সহজে একটা ডিস্টেন্স এইচ,
হ্যাঁ তো
টাইম
মানে
থ্রু স্টপ ওয়াচ।
হ্যাঁ
এটা মেজার যে করতে হবে আমি এক্সপেরিমেন্টের সময়, সেটা তো চাই। এনার্জি কনজারভেশনটা আমি লিখতেই পারি। এনার্জি কনজারভেশন যেক্ষেত্রে আমার এনার্জিটাকে আনতে হবে, এনার্জিটাকে কি আমি মেজার করতে পারবো ডিউরিং দ্য এক্সপেরিমেন্ট কোনোভাবে? ইনিশিয়ালি আমি পারবো যে ইনিশিয়ালি হোয়াট ইজ এমজিএইচ।
হ্যাঁ
এমজিএইচ
হ্যাঁ
ইজ দ্য টোটাল এনার্জি স্টোরড। যখন ওই ফেজটা চেঞ্জ করছে ওই মুহূর্তে কত এনার্জি এদিক থেকে ওদিকে গেল আমি কি করে সহজে মেজার করব?
না মানে একটা পার্টিকুলার হাইট এইচ অব্দি তো ছিল মানে মাসটা, তারপর
হ্যাঁ,
তো এইচ
টোটাল
থেকে কাম
এনার্জি,
ডাউন করলো। হ্যাঁ তারপর
টোটাল এনার্জি।
হ্যাঁ তো ওখান
তারপরে
থেকে যদি বা
এনার্জিটা যখন মাসটা হিট করলো কিছুটা এনার্জি তো ওখানে লস হয়ে গেছে গ্রাউন্ডে যখন হিট, সেটার তো কোনো মেজার নেই আমার কাছে।
ও আচ্ছা 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 তারপরে এনার্জি কনজারভেশন হচ্ছে না অ্যাকচুয়ালি এখানে।
এনার্জি কনজারভেশন ওই স্টেজে হচ্ছে না, কিন্তু ওই স্টেজের আগে সেপারেটলি হচ্ছে, পরে সেপারেটলি হচ্ছে।
হ্যাঁ হ্যাঁ হ্যাঁ
কিন্তু এনার্জি এখানেও আরেকটা মানে কিন্তু আছে, সেই কিন্তুটা হচ্ছে এই ফ্রিকশনাল রেজিস্ট্যান্স। এর জন্য কিছু এনার্জি ডিসিপেট করছে, আমরা অ্যাকচুয়ালি সেই ডিসিপেশনটা এক্সপ্লিসিটলি আনছি না, আমরা ইকুয়েশন থেকে এই এম ফ্রিকশনটাকে এলিমিনেট করে দিচ্ছি। কিন্তু
ও আচ্ছা আচ্ছা
so this is the way how we will measure this. Actually our measurement will be this h. Before starting the experiment we will measure it, and after that we will release the falling mass. During the experiment we will measure 2 times through stopwatch. Each run will measure 2 time interval. One is t1. T1 is the interval of time starting from the release of the falling body, and it will end when the falling body just hit the ground. And T2, another time interval we will measure. T2 will start from the same instant. It is when you release the falling body, but it will continue after the measurement of T2 will continue after the falling body hit the ground. And it will end just when the flywheel will come to rest momentarily. So H, T1 and T2, these are 3 measuring parameter here. You just see the experiment lab sheet, we have H, T1 and T2. So these values for the demonstration, we obtain these values. So this is another chart where values are obtained. So 0.2 meter, 0.3 meter and 0.4 meter. The falling body is released from rest from a height in the first run from 0.2 meter, the second run 0.3 meter, then third run 0.4 meter. Now first stopwatch which will give the reading of T1, it will be 4.34, 5.58 and 6.22. Second stopwatch which will give the reading of T2, it will be 139.43, 163.90, 196.88. These are the reading. Now I will just run the demonstration video. Possibly will not get any sound. I don't know how to share the sound, but I can share the video. So observe this video, then I will come back again. Are you finding the video file? Is it okay? Did you find it?
Yes, sir.
Okay. Now I am starting the experiment. Hopefully you are not getting the sound.
No, sir, we got the sound.
You got the sound?
Audible.
Okay, sound is audible. Then Okay, this is the experiment. So do you have any question here?
সে এটাতে তো তার মানে ফ্লাইহুইল বলতে মানে ওই ইনক্লুডিং দ্য শ্যাফট আর কি, তাই তো? মানে সবই তো ঘুরছে।
টেকনিক্যালি দ্যাট, বাট সব ঘুরলেও শ্যাফটের রেডিয়াসটা খুব কম, মাসটাও খুব কম, তার ওর মোমেন্ট অফ ইনার্শিয়াটা ফ্লাইহুইলের নিজস্ব মোমেন্ট অফ ইনার্শিয়ার সঙ্গে অনেকটাই কম। তাই অ্যাকচুয়ালি আমরা যে মোমেন্ট অফ ইনার্শিয়া ক্যালকুলেট করছি ওটা অ্যাকচুয়ালি ফ্লাইহুইলের মোমেন্ট অফ ইনার্শিয়াটাকেই বোঝাচ্ছে, পার্টিকুলারলি রেডিয়াসটা কম বলে।
ওকে স্যার।
তো this is the chart you have to fill up. This portion is the observation which has been shown here in this chart. This observation, based on this observation data, you will perform your calculation. So after the observation, you have to fill this chart. This is the A, acceleration of the falling body, final velocity of the falling body before it touches the ground, then maximum angular speed of the flywheel, then frictional deceleration, then acceleration of the flywheel as the body falls. This thing can be calculated for 3 different runs, and from this you can calculate this torque on the flywheel, torque applied on the flywheel by falling body. Here, as it is also mentioned in during the demonstration, this G outside this bracket, this G is erroneously printed here. So that will be T equal to mR0 into G minus A. You should not consider this G. In that case, there will be mistake in your calculation. So from this, you can calculate the mass moment of inertia of the flywheel from this relation. And after that, mass moment of inertia, you can calculate the radius of gyration of the flywheel. Total mass of the flywheel, MF, will be given. It is given, mass of the flywheel, 140 kg. Mass of the falling body 12.8 kg. Radius of the shaft 0.0254 meter, and acceleration due to gravity is also given for your calculation. So your task will be to complete this object, and accordingly you have to derive the working formula also. The part which will be included in the report I will mail to you, and you will complete all the reports together. Prepare a single PDF file for all the reports. For each experiment, you will prepare one report, and together you will make one single PDF file combining all the report. So at the end of this experiment, all the classes, when all the classes will be over, you will submit that single PDF file to me as a report. Is it okay? So in the next week, you don't have to submit the report, but you try to prepare the report.
Okay, sir.
So in the A4 size blank page, you will complete these charts starting from this table 1 on the previous page. This will be your observation and this will be your results. And finally, conclusion will be the average value of mass moment of inertia and average value of radius of gyration. That will be your conclusion. Is there any
And so,
question?
do you have to make any type of title page or anything?
Yes, I shall mention them in a separate mail. I will send what you have to include in the report.
Okay, sir. Okay.
স্যার
Yes.
স্যার এই পেজটাই প্রিন্ট আউট করে ডেটাগুলো লিখলে হবে না শুধু?
হ্যাঁ, সেটাও হতে পারে। কিন্তু সেটা প্রিন্ট আউটের কস্ট লাগবে। তার থেকে তুমি যদি এটা হোয়াইট পেজ এটা তৈরি করে নাও।
হ্যাঁ, মানে কারো কারো বাড়িতে তো প্রিন্টার থাকে স্যার।
হ্যাঁ, সেটা হলে ঠিক আছে। সেটা হলে ঠিক আছে।
আচ্ছা।
In that case, এই ফাইলটাও ইনক্লুড করতে হবে। এই পেজটা, এটা অবজারভেশন চার্ট। Okay, then I shall conclude the class here. So we'll meet on the next week again for the next experiment. Before the next experiment, I will send the demonstration video for the next experiment.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, sir.
Thank you. So one thing I forgot, I did not record this class. Anyone has started to record?